Okay, so we'll back to this. So first we'll see what is a CPU, central processing unit. You know that one already. Okay, so different type of CPUs, different type of manufacturers and CPU manufacturers are there. So main central processing unit. Okay, okay. So like Intel, AMD is the main in a competition. VIA is a old type now. VIA is not available. Motorola, mobile and other devices, not in a computer devices. This is a different CPUs, how it is look like and how it is going to on a motherboard. In CPU, we have to see few things. One is like a speed, bandwidth. So it's a instruction bit. Okay, front side bus and cache memory. So compulsory we have to see the speed of the CPU. Speed we have to check it. So how many gigahertz speed it is there. So how to check it how much speed it is there. So generally like for example, just for example, so at 2.60 gigahertz CPU, just for example, so you have to check it. So how many gigahertz CPU it is, we have to check the CPU thing. So the width is what type of bit it is. Okay, so what type of bit it is, you have to verify. So 2.60 gigahertz. Okay, so bit width like a 32-bit type of processor is there. 64-bit processor is also there. So we have to what bit processor you are using. That is also very important here. So for example, here it's a speed it is mentioned, see 3.4 gigahertz speed, and of course it is a 64-bit only. Okay, so maximum memory size is a 32 GB. But no uh, details are not much, but you can go through this. Like if you put it and search in a Google, like you can get Arc Intel. So search here what bit it is, how many cores of CPU. Currently we have a core CPUs, right? So how much frequency, how many cores, how many threads, these threads are there or not, how much maximum memory supported, what type of RAM it is supported. Okay, memory type it is supported. Okay, and I'm going down. It is Intel virtualization supported or not. Okay, virtualization technology supported or not. And instruction set is a 64-bit. Okay, instruction set 64-bit Intel 64. Okay, and what are the instructions are there in a CPU. So these are the things we have to check in your CPU currently while you are purchasing. So whether it is 64-bit or not. Okay, so max RAM size, max memory support. Just for example, 32 GB RAM. Okay, so like that it is maximum memory support. You have to check it. Virtualization technology support is there or not. So for example, VTX, one of the virtualization technology. Instruction set is also 32-bit or a 64-bit instruction set is there. Next, how many cores are there? So for example, two cores. How many threads are there? How many threads are there? So you can see here the threads sheet is showing here. Threads 4 and 2 is a thing is important. Okay, next, just writing here, it means example purpose only. uh, just for example, how many cores, how many threads, sometimes no threads, sometimes threads are there, sometimes double, sometimes same, two core, two threads, four core, four threads, or two core, four threads. So it is like that. Okay. Cache memory. So the very important one is cache memory. How much cache memory it is there? For example, 6 MB. Just for example, how much cache memory is there? L1, L3 cache memory. It is generally L3 cache memory. How much cache memory we have? Okay, the cache memory is important. Okay, and graphic memory. Okay, so how much graphic memory the processor having? Sometimes certain processors don't have any graphic memory. Okay, sometimes the processor don't have a graphic memory. This is having some graphic memory, so you can see processor graphic is SD graphics 2500. Okay, they are having some graphic memory, some frequency for the graphic thing. Okay, graphic memory is there. Sometimes no graphic memory. Last time I purchased my processor, that is don't have any graphic memory. And it is usually a primary memory only, not secondary memory. The cache memory, very good question. So, why you ask one question is cache memory is a primary or a secondary memory? So, cache memory is like a primary memory only, but it is inside your CPU. Okay, if you are see the CPU, the CPU has cache on itself. Like CPU, this is a CPU, and generally like this side memory where the primary memories are there connected, so that side only. Okay, cache memory will be there. Cache memory will be there at a side of my memory. It is on the chip, it is not outside the chip. You can't remove the cache memory. It is comes with your CPU only. Okay, so it comes with your CPU only. Okay, next one. Next, when you are maximum supported RAM size, also what type of RAM it is supported. Okay, so either it is like a DDR3 type or a DDR4. Okay, mm, what type of thing it is? Either it is like um, a megahertz frequency or a 1600 megahertz frequency, or maybe a 2400 megahertz frequency. So different type of megahertz frequencies are there. The speed of the RAMs also different types. So what type of RAM it is supported? DDR3, DDR4. What type of memory it is supporting? Also we have to verify. Okay. Of course, FSB means the clock speed only. Okay, front side bus, back side bus. Okay, sorry, FSB is different one. FSB is nothing but FSB, front side bus of a CPU. So the front side of bus of CPU will decide what type of RAM and what type of frequency of the RAM is supported. Okay, so this is the things we have to look at a CPU. Okay, when you purchasing a CPU, so these are the things we have to do it. Okay, in CPU you have a different type of CPUs are there. Single core CPU, multi core CPU are available. So you can say single core CPU will be there, means only one core, like a Pentium 1, Pentium 2, Pentium 3, Pentium 4, cell run processors. These are all single core processor. Dual core processors also available. Okay. Dual core means two CPUs combined together and become a single CPU. Okay. dual core processor. Next is a multi-threading processor, means multi-core processors also there. Just like multi-core processor means core 2 geo processor. It's maybe you hear this one, core 2 geo processors. Multi-core processor like octa-core, deca-core. So we seen that one, no? So that is a single core processor is divided into multiple processor. Means dual core means a processor. This is single core processor and took another single core processor combined together. It is a dual core processor. It contains a common cache memory. It contains a common cache memory. What is this cache memory? Cache is nothing but a SRAM. The cache memory, cache or a cache, we can spell cache memory is nothing but SRAM. Technology used is a SRAM technology only. It is only it's a very temporary memory. It won't store much time. When our system is down, cache memory will be clear. What is this cache memory will do? When you start your PC, it load instructions from the ROM to RAM. Actually, instructions load to ROM to RAM and RAM to cache memory. So cache memory to CPU, actual CPU. The CPU again two parts, major parts are ALU and CU, control unit and arithmetical and logical unit is there. Arithmetic logical unit, control unit. So this cache data means data and instruction. Cache memory contains data and instructions load into your CPU. When CPU is doing process, it puts some data into the cache memory. Okay, and also the cache memory will write the data into your RAM and RAM to others. Okay, so that is like RAM directly won't interact with your CPU. RAM load the data into cache load the data instructions into your CPU. CPU again put the data into the cache and cache to RAM and RAM to other devices. Okay, so like your input output devices and your hard disk or CD-ROM won't connect directly to CPU. They don't load any data into CPU directly. Okay, so anything through RAM only. So you are giving a input is going through RAM to CPU only. Okay, so this is a cache is a vital very important role in a CPU processing. Higher the cache, CPU performance will increases. Normally we don't use entire CPU part, but we're using cache. We can you utilize your CPU function more. Why? Because of we can load into the cache to CPU is much faster. We can able to load the data and instructions. So in dual core, in single core we have one single cache memory. In dual core also we have a single cache memory. It means from RAM, when you load instruction to the cache will load instruction to the CPUs. Okay, so it will share it, so double the speed your process will be done. Like if you are doing with one single process, so the double the speed it will run the your process. That is the use of the dual core processors. Next one is core 2 geo model. So this core 2 geo model means it's a single processor only. It is divided into two parts. It is divided into parts. It's a single processor is divided into two parts. That is called threads. Two threads, one CPU, two threads type. So here it is also has a cache, but the cache is divided into two parts. So separate cache for each core PC is there. So whenever you load an instruction to the cache is load instruction to the one single core PC only. This is called core 0. This is a core 0 and this is core 1. So I load an instruction to one cache, then the cache is going to this one. Next, for example, I run a two process, one process to the one cache, one core, and another process handled by this one. So it means, so multiple process we can able to handle, and we can able to easily we can work with that. Earlier days when I was working with computers, that time means started computer times. I have a, Celeron processor, a 95 operating system, 98 operating system. Okay, that time XP system will hang every time. Okay, so when I use two three multitasking, like one is word process, paintbrush, and PPT, obviously system will slow, and obviously system start hanging. So there is a two reasons. One is RAM size is one of the reason. Second size is system cannot handle more traffic. Okay, on a CPU cannot process, unable to process all windows in it. Of course, whatever the CPU you are using, if you are keep on open lot of windows and all, system cannot able to handle it. Okay, so that's the thing. Okay, but still in a old days we have a lot of hanging of a system is there, system got hanged. But now that is very very less situations, because of, we have a very good RAM capacities nowadays, and as well as multi-core processings will able to handle the your task very easily. Okay, so that is a multi-core core to geo core multi-core processors, so we are using nowadays. Okay, one second guys, I want to check this one. So, okay, so uh, next one is any newcomers are there also, please tell me, I will add it. Okay, it's a good question. Ask me questions also, it is easy for me to go through once. Okay. Next, in CPUs we have a 32-bit CPU and 64-bit CPU is there. What is this bit CPUs? What is this 32-bit and 64? It is also important question sometimes. Last few interviews they ask what is the difference between 32-bit and 64-bit processors. Actually, Intel started with a 400 processor, which is 4-bit processor in a starting. Okay, then later it is implemented like a 8008, then 8080 processor, 8081. Like it is keep on developing, and finally they came to 8085, 8086 processor, and then they developed 8086 only, because they found lot of very good thing about 8086, like 80186, 286, 386, 486, 586. Okay, Pentium 1, Pentium 2, Pentium 3, Celeron, Pentium 4, Pentium 4 Extreme, Dual Core, Core 2 Zero, Pentium Gold processor. Okay, so different Celeron processors. Okay, there are Pentium M for laptops. Different processors are released. So then here it is 16-bit processor, 16-bit processor. It is keep on 16-bit. Then they released a 32-bit processor. Now 64-bit processors are going. What is this bit? In generally, when you see a bit processor, it means there is a buses are there. So major buses are address bus and data bus. Address bus and data bus. The pin numbers are different from each thing. Okay, so 32-bit processor having a 32-bit address bus and 32-bit data bus. 16-bit processor having a 32 16-bit address bus and 16-bit database. So usually it is a bus width will tell us what is the bit processor it is. Another one is instruction. Okay, instruction bit length. Okay, so instruction bit length. So in a 32-bit processor, we have a 32-bit instruction. In a 64-bit processor, we have a 64-bit instructions. On CPU itself, have a certain instructions are there, and on the CPU itself, have a some instruction set is there. Okay, so different type of CPU instructions are there. One is CISC, another one is RISC. CISC and RISC type of processor are there. Complex instruction set computing, reduced instruction set computing is there. We are using a CISC type of processor. Okay, so complex instruction set thing only. RISC based processors also available in market, but we are using a CISC one only. Complex instruction set computing, reduced instruction set computing. This is having less instruction. This is having a more complex instructions. And inside a CPU, these instructions are available. If you go through this, I can show you these instructions. So these are the just for example. Just for example, these are the instructions. Okay, these are the instructions in a CPU. So depends upon the instructions. Depends upon the instructions. Okay, CPU function also is there. So VTX is also a instruction. VTX is also a instruction in the CPU. That's why it is supporting virtualization. If VTX is not there, it won't support your virtualization also. Okay. And next one. So instruction is inside a CPU, as well as we are giving some instruction to the CPU, right? So I want to add a two numbers, 4 plus 3. 4 plus 3 I want to add a 4 plus 3 I want to add a in this one. So what I'm giving a data, two data, so I'm giving 4 and 3, and I want to add it. It means additional function should be done. That is a instruction here, right? So I'm giving this instruction to the CPU. I'm asking CPU add 4 plus 3, add a 4 and 3, not 4 plus, it's a add a 4 and 3. So what will happen, system will understand additional function, and then take a 4 value and 3 value, add it, and then it will produce the result, right? It will produce the result as a 7. How it will understand? Because of internal CPU instruction and external instructions we are giving this one. Okay, so every CPU has its own instructions inside, and as well as we are giving instructions, so then it will understand our instructions. It so this instruction set length, okay, is 32-bit in 32-bit processor. Okay, and 64-bit in a 64-bit processor. Very simple to say 64-bit in a 64-bit CPU. Understand? I think so. And this is also more. I don't want to put a more things in this system. Okay. So understand instruction bit. It means if 32-bit instructions we use in a 32-bit processor, and 64-bit instruction bit length in a 64-bit instruction. So both what are we given instruction and what it is understand instructions is based on that one only. Okay, this is the first thing. Second one, operating system. For example, you are using a CPU 64-bit, and you have to use 64-bit operating system only. Okay, and of course device drivers also there. So I write only drivers, device drivers. It is also in a piece of program. It is also must be 64-bit, and applications also must be a 64-bit. Okay, of course nowadays applications can be 32-bit also possible. So that we'll add it later. Okay, if you are using a CPU 32-bit CPU, then operating system must be 32 only. Don't install 64 even if it is accepted or not. So that's a different thing. But always follow the same bit, so then we can avoid a. Of course, 32-bit also support sometimes 16-bit applications. But here is the important thing: once you are using a 64-bit CPU, operating system, drivers, and applications must be in a 64. It is more compatible one. If you are using 32-bit CPU, 32-bit uh, 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 drivers, 32-bit applications, 32-bit operating system only. Next, 64-bit CPU having a certain features also there. That's makes the difference between 32 and 64. Okay, so it support more memory. It means like 32 GB, 64 GB, more memory required and more memory support. So it required more memory required, and as well as support more memory is there. Virtualization. Okay, core virtualization support is there. Virtualization support is there, like a VTX or AMDV support is there. Okay, we can run big applications. We can run um, um, big applications. We can run applications. Of course, we can say like a big application. Just for a word only, it is. I am not going with a suitable word. General, I am using big application means heavy applications. Big or heavy application, bigger heavy applications we can able to run very easily, because in the instruction is very good. Okay, video also, video kind of stuff also we can process it. We can process the big application or heavy applications in a 64-bit. Okay, and the lot of 64-bit. Few may not support, but maximum 64-bit processor support Intel virtualization or AMD virtualization support is there. It required more memory to run the program, but and also to support more memory modules. Also, we can able to increase it. So that is another feature of your 64-bit. Okay, of course, secure secure boot is possible. Okay, it support UEFI um, firmware. It means nothing but your old style BIOS only. Okay, it's like a BIOS only. Okay, BIOS is a previously and currently we are using a BIOS as a firmware, and we are using a UEFI currently. Okay, so this is two things: secure boot possible, UEFI support is there. Okay, GPT type of partition table is we are using. It supports GPT because we are using UEFI. So 64 also comes with UEFI firmware, firmware or firmware, anything you can tell. And UEFI supports GPT partition table. Okay, so GID partition table, like hard disk supporting. Secure boot is possible because of UEFI. These are all subset of UEFI. Because of UEFI we are getting these two things. Okay, so these are the 64-bit features. um, I think we got a point. What we look at a CPU speed and what bit it is, what maximum RAM support, type of RAM which is supported, virtualization technology supported or not, how many cores, how many threads, how much cache memory, how much graphic memory we are getting in through with the CPU. Okay, and CPU single core, dual core, multi-core processors are there. 64-bit type, 32-bit type processor is there. Yeah, the bit type is depends upon the instruction set. 32-bit instruction set in a 32-bit CPU, 64-bit instruction set in a 64-bit CPU. Whenever you use 64-bit CPU, then you have to use operating system 64, driver 64, application 64. Okay, and if you are using 32-bit, and everything must be in a 32-bit. 64-bit processor is recommended. Why? Because of it supporting lot of things. It support more memory and more memory required for a functioning, and as well as support more memory also. Okay, and also it will support virtualization, which is a very key feature nowadays in our system. Okay, so it run a big and heavy applications in our system. You 64-bit also support UFI firmware, like a BIOS firmware we are using. Okay, so it support UFI. UFI support GPT, GID partition table, and secure boot. So these are the things about your basic CPU. Okay, uh, one or two troubleshooting things also we will discuss. No questions. Okay, uh, just a CPU. I'm going to new dot. If you see any CPU, CPU is fitted into the socket, so it is they fit into the socket on a motherboard. Okay, just like this is a motherboard. Think like it is a motherboard. Okay, one second, guys. Okay, so it is on the motherboard. They put a into inside a socket. Okay, now on the CPU there is a heat sink. So remember, this is a heat sink on the uh, on the CPU, and on the heat sink there is a fan assembly. On the heat sink there is a fan assembly, and there is a heat sink paste is there. It is a adhesive. This is a heat sink paste which is in between your CPU and a heat sink. Okay, this is a one single unit, so completely become single unit. So why we need a heat sink? CPU generate lot of heat. CPU generate lot of heat while it is processing. Okay, so more heat it is like you can it is just like a induction plate only. Okay, when CPU is processing, it is, yeah, this is a CPU is look like this one. It is sitting into this kind of so you can see this is a socket. So you just insert a CPU, close it, just like you have to do it. Open this one, put it and close it. This is the back side, going inside like this. After sitting, it is look like this one. Okay, you can see it is from the motherboard side, like a cabinet inside. It is there. On the CPU, you have a heatsink paste on it. On the CPU, you have to apply a heatsink paste. CPU heatsink, first I will put a heatsink. These are a different type of heat sinks. Okay, so if you go to AMD type, you will get a heat sink is very heavy, because AMD processor generate lot of heat compared to normal Intel processors. So we need a more heat sink thing. It is nothing but some aluminum alloy type. These heat sinks are aluminum alloy type, and with the copper contacts it's also there. What is the duty of this? Some are having a copper rods like this. Okay, what is the duty of this heat sink is it will observe the heat. It won't cool the CPU. It cool the CPU by observing the heat from the CPU, observing the heat from the CPU, and it will exhaust outside. Okay, heat will go outside of the this unit. by running this fan assembly. Okay, what happens? CPU is getting cooler. It's not actually not getting cooler. It is maintaining a normal temperature only. Instead of getting overheated, it is in the normal temperature only. It is in the its self set temperature only, not heavy temperature. Okay, the temperature, what are the heat which is generated from CPU will absorb by heat sink, and it is evaporated outside only. So this is one thing. Second one is, what is this heatsink paste? I said, okay, um, this heatsink paste apply on a CPU, and we put a heatsink on it. So it can be shown in somewhere. That's why I'm searching. So whatever it is, that heatsink paste create more contact. Okay, create a more contact between. Okay, so I will show you this first. This heatsink, because this is normal desktop. This is a laptop heatsink. You can see a laptop heatsink like this. Here under this one, CPU will be there. The fan assembly is a separated one. Heat will transfer this copper rod, and the heat will go outside of the your laptop. By using this fan, it will go out. Like, you can check it your laptop side. There is a breather is there, means holes are there. Through that one, it will go heat outside. That's why make sure that this fan assembly always clean. Okay, don't put your laptop on laptop means desktop means you put a system on a desktop, means in a table, that is called desktop. Desk means table, and you put it on a table, then it is means it's like a desktop, right? Laptop means you can use your lap, then you can put a lap, you can work with it. You don't require desktop for that one. So it is laptop, but don't use, never use your lap as a lap. Don't use your laptop on your lap. Don't put your laptop on bed. I've seen lot of people, including myself. I put a laptop on my on a bed. So what will happen? Bed contains, even if you know or not, the lot of dust particles are there. Those dust particles will absorb the dust particles, and as well as the cloth will block the air for your laptop breathers are there, no, the holes. It cover the holes, so automatically CPU will get heated, means your inside your system, your laptop is getting heated. That heat affect on your battery, the battery getting weak, and battery will get more heated, and finally it will damage internal parts. The most of the laptop within a 2 to 3 years, it is getting damaged major because of you are putting a laptop on a bed. Some people put a paper, books. Better to use some a plank. Better to use a plank under your thing, or give some gap like the cooler things. You nowadays we are getting a cheap sheets also coming, so it will give it create a little bit gap. You don't require a laptop cooling kind of stuff. So this many laptop cooling kind of stuff, it is not required. Like a fan things, okay, this is okay. Like this is that much not required. 1500, 2000, 3000 rupees not required. Okay, like this very cooling things. Okay, that much is just for a thing only. Just use a very simple stand type, or maybe a sheet type, very basic sheet. You will get it, which is won't block your backside. Um, like this. This is a more very thin holes net type you're getting. See, this is a completely net free, air free. You know, I asked my one of my brother told me, one of my cousin brother told me that they use a egg tray. When he was in a Delhi, like to getting a cool PC, they use a egg tray because it's more pop-up kind of stuff, right? So more gaps are there, more it is giving cool compared to the cool CPU cooling things. So you don't need to put more money to buy all these things. So simple one, or use a very simple plank also. It is very easy. Like your exam pad is there, right? So you can use your exam pad also. Okay. Next one is this is a thermal paste on the CPU. Like apply a thermal paste and put a your CPU fan on it. So you can see these things. Different thermal paste available in the market. This some are little bit costly. Some are with the 10 rupees dabba also available in market. Okay, so depends upon your system, depends upon your budget. You can use 10 rupees dabba, 10 20 rupees maximum price, or maybe you can use like this 200 rupees or 150 rupees uh, thermal paste. Everything works fine. This is a little bit costly, the injection type with a smaller size. Okay, like this is a little bit costly, but depends upon you and what how much you are using. You have to apply like this and put a fan assembly on it. So what is the advantage is it will give you more contact between your CPU and your heat sink, and it won't evaporate in a 1 year or 2 years. Almost like a 5 to 10 years this heat sink paste will work. Okay, so that's why this is I'm telling. Okay, so this is a heat sink paste, heat sink assembly fan. Don't use a blocker, so don't put anything up blocking this air venting for both desktop and as well as the laptop also. Okay, now the thing is what will happen if I said CPU, then heat sink, thermal paste, then heat sink. So I said thermal paste, CPU thermal paste, or heat sink thermal paste, heat sink, and fan. Okay, so it is an exhaust fan only. It will take heat outside. Okay, here if you clean up your heat sink paste, or maybe you didn't install heat sink properly, or maybe you are blocking your fan, or fan is not running properly, or fan got a dust. So another one is also there, I forget this one. Okay, uh, this is the fan assembly, where the fan assembly. So I will show you, try. Yeah, okay, can you see this fan assembly? This fan and heat sink sometimes get more dust inside. Last time it is happened in our 70s in a Pune center only. What happened? Some systems are in a last of the vein. In a entire, we have almost 25 working, currently working PCs are there. So total 30 PCs are there actually. We use certain PCs for separate purpose, like a demo and front office purpose. But in a backside of the there is a PC. It's not closed properly. Also, the enclosure is not closed properly. What happened? It is near to the window. Entire dust is occupied onto this one. Okay, the entire dust. It is completely dust particles. Completely dust is there. So what happened? So our guy is working. So every 2 to 3 minutes, system is getting restarted automatically. I got a doubt, so it is not showing any error, no blue screen error, nothing is there. So why it is getting? So I didn't get why it is system is keep on restart after 2 3 minutes of working. Okay, so the guy is working that every time. system is restarted, is unable to do practical also. So I said, just wait for a 10-15 minutes in the break time. So I open the cabinet and see the fan assembly and heatsink assembly. It's completely dust. So I took a brush. So normally you can see a paintbrush type is there, no, one inch or half inch brushes are easy. So I took a brush and clean up this heat sink and a fan completely, and I put it back. So then we started. Then now it is working fine. So what is a thing? What is the thing? If you miss your heat sink paste, one is a heat sink paste. So then processor getting heated, CPU is getting heated, and the heat should be passes through heat sink and fan. If heat sink paste is not there or properly not there, or it is cleaned, so what happen? The heat won't go to the heat sink and then fan also. So you have to make sure that heat sink paste is good or not. Second, heat sink is properly installed. Second one is it covered with dust? Is it covered with dust? That is also important. If it is a covered with dust, the fan won't get heat and fan won't operate your heat and fan won't run properly. So what happened? CPU heat cannot be escape from CPU. CPU heat is cannot escape from the CPU. So CPU will get overheated. What will happen in this case? CPU will get overheated. So when it is overheated, to protect CPU from damage, means it will burn. CPU will get overheated means CPU will burn automatically. So damage, what system automatically, the system automatically reboot your PC. It keep on restart. Okay, it reboot system automatically. Okay, so that is the thing. So when CPU is getting overheated, what will happen? To protect CPU from damage, it automatically reboot the system. It reboot the system. Okay, so to protect it. So when you see you start a PC and it is not showing any error, but system is getting booted. System is booted and rebooted, rebooted. What will happen? So it's frequently rebooting it without throwing any blue screen error or any other errors. It is a mostly because of either thermal paste, heat sink, or fan assembly. So there is a issue in these three things. You can able to check it. So this is how we can able to troubleshoot. Yeah, someone is asking question. Go for it. Answer. No problem. Asking. If you cannot, otherwise you can put it in a chat box also. No problem. Okay.
Hello.
Yeah, tell me, guys. No. So now really the what I expected that question is came. This is Prerna is getting problem, but Sneha completed interview cases. What is diode? Real time example. What is the difference between 8086, 8085, 80386? No one will accept that one. Okay, no one expect that kind of question. It is. What are the types of multiplexing? You know, you don't. So what is a GSM and TDM? What are the types of transistors? What is op amps and functionality? Difference between whole number and natural number. What is flip flop? Interviews did not ask single question about topic and a study in training. That's a good thing.
It seems like she's from electronics branch.
Yeah, it is from she's from electronics background only. But It is just for fun. They will ask also sometimes. Sometimes, the basic idea of what you studied in engineering. Okay, they don't expect to give exact answers also, but what idea you have, what does you remember from it. And
But sir, if we are not able to give the answer, so is there is possibility that they will reject us?
no, 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 no. It is not like that. Of course, if they rejected based on this one, then definitely a big problem. But usually they don't go for it. And second one is generally what we studied. We have a basic idea. So give answer based on a basic idea only. Okay, that's why open up your mind. You know the answers. Actually, we know the answer what we studied in engineering. Only thing is, at the time of interview, we think only about our subject only. But once you are open your up, like for example, we sit together just for a tea or coffee, something like sit together. We'd start discussing about any of this one. Usually, we'll give the answers. you know. So like diode,
Yes.
any ECE electrical people remember diode it is. But at the time interview, you cannot able to speak about it. But this interview is very dangerous. Like if they ask almost like this one, like whole number and natural number, I didn't remember anything about it. Whole number means it's a number only. Natural number means what it is. I remember op amps, transistors, GSM and TDM is a mobile technology. Earlier we used a time division multiplexing, then we got a GSM technology later. Type of multiplexing I didn't remember. Multiplexing, demultiplexing, I remember only one thing. I didn't remember type of multiplexings. Just now only we are discuss about these things. I know 8085 and 8086, one or two differences are there. Diode I very well known. If I got this interview, I will pass in this interview. I know flip flops. Even my engineering at 2008, I completed my engineering. Okay. Uh, some interview is there. Sawmill interview. It is. So we'll go to this one. About myself, switching career paths and all. Okay. These are good questions. Guys, every day you have to study for any basic questions you want to ask. These questions occasionally they will ask wantedly. They ask occasionally. It is does not mean that um, you are not at all good. Okay, so they must ask in a training only. It's okay. If you don't give an answer, also sometimes it's okay. But if you have an idea, then you can able to give an answer. Okay. So that's why why I'm telling this heatsink and all. It is not there in a syllabus, but it is a general idea. Of course, I can't speak about the transistors, what is CMOS and all kind of stuff, entire structure of hardware structure. I can't discuss it, but this is a general idea. People who are using a computer, they should know the basics. That's why I personally take these classes. Usually, no one, including I don't know whether it is in Hyderabad, there are taking care of this part or not. Even I don't know, but I don't know other organizations who are dealing with the cognizant and other people. But I'm personally suggest to know what is 32-bit, what is 64-bit, what is CPU, what is heat sink. So because of it's a general issues, are so we are getting our personal issues. First of all, we have to deal with our personal issues, and second one is in a working area also. If you got issue, you should know how to deal with it. Every time you cannot depends upon the technical guy. Okay, uh, so cache memory is there in every CPU. So in a cache memory, L1 cache memory, L2 cache memory, L3 cache memory is there. In olden days, only two cache memories are there. Then another one is add up into the CPU, that is called a L3 cache memory. You know how it is like in a layer wise. If you want to see in a layer wise, if you say this is actual CPU part on the CPU, this is the layers. Like this is a L1, L2, L1 cache memory. This is L2 cache memory layer. This is L3 cache memory layer. In the L1 cache memory, we have a two parts again. Okay, so one is like L1, okay, then L2 and L3. And in L1, so again, the first layer is like L1 cache memory, L2 cache memory, L3 cache memory. These are three cache memories. And why I divided this one? Because in L1 we have a instruction cache and data cache is there. Okay, in L1 we have a instruction cache and data cache. That's why it is divided like this. If you want to know about cache memories, if you are using a Windows 10 PC, then easily we can know it. Go to Task Manager. Okay, same thing like yesterday's CPU. You can see from here the cache memory, how much you have it. So L1 cache memory 128 KB. It means 64 KB for instruction cache, 64 KB for data cache. Very small size, but it is very high speed because very near to the CPU. On the other layer, it is L2 cache 512 KB cache memory and 3 MB cache memory. Very small cache memory as compared to nowadays. But if you go to any CPU related information, okay, you can get what is the cache memory from there. Already we seen 6 MB cache memory and all. So in my system, I have a 128 KB cache memory, so it is always in cap letters, and 512 KB cache memory, not even a 1 MB also. I got a 3 MB cache memory. Just for example, cache memory is in a sizes only. Cache memory's speed is equivalent to CPU speed only. Okay, the cache speed is nothing but what happened? Nothing but CPU speed only. Cache speed and CPU speed are same speed only. We don't need to say like this is cache speed, this is a thing. Okay, cache speed and CPU speed is always a same speed only. Okay, in generally CPU load take and load instructions. Okay, so to cache only. Of course, first L3 cache, L3 to L2, L2 to L1, then CPU. Okay, and it load instructions and communicate with RAM only. Okay, of course, after this one, other devices means IO. It communicated to and fro other devices to from RAM. RAM is communicating. It's a two-way communications. IO devices, input output devices, memory devices like a hard disk, BIOS chip means ROM or BIOS chip. Okay, so these are devices like communicating with other devices. Just for telling north bridge, south bridge. These are it is communicating with other devices. Okay, this is the main communication. Primary communication is RAM load instruction to the cache, cache load instruction to the CPU. CPU put a memory into cache, cache to the RAM. This is the way it will work together. This is work like a single unit only. And RAM is interact with all other devices through north bridge and south bridge. Okay, there are the two bridges are there. So this entire communication is handled by north bridge. It's another chip. Okay, and RAM to other communication like other devices. like a PCI, PCIe, other communications through South Bridge. So through South Bridge only. So this is how it is communicate. Okay, so I think you understand the cache memory. The more the cache memory, faster it will work. Okay, so this is about your CPU. I'm going to